All right, well, thanks, Jess, and welcome to all the attendees. As you have questions, Jess and the team are going to be moderating questions in the chat window, so we'll get a chance to ask Bill a couple from the crowd. I think it's safe to say that 2020 was a year about big problems, from a global pandemic to a pretty complex political landscape. Humanity's been presented with some of the biggest philosophical and technical problems we've ever seen. At the heart of that, the good news is that human ingenuity is limitless, in my opinion. We're programmed to be curious, and we want to solve problems, so there's hope. And software engineers, like many of you out there, know this better than most. How many of you had to, solve a problem because CEO promised the customer something, right? It's not like I ever promise anything to them. But seriously, humans are great at solving big problems. I bet each and every one of you are trying to solve some sort of problem right now and tackling it. My own passion is I'm trying to automate consumer privacy in large corporations. To talk about how any one of us can use the principles of science to solve any problem, I'd like to introduce everyone's teacher, Bill Nye, the science guy.
Greetings, greetings. Carry on. Let's get started. Let's see. Two huge problems. Pandemic, global pandemic, first one since 1918. Oh, those were the days. You guys, if you've never been to an old cemetery and seen all the tombstones of very young people 8 years old, 7 years old, 50 million people killed worldwide by the flu virus. We're living through another pandemic that probably won't be that serious in numbers, but it's very serious economically because the world is so much more dependent one country to another. This is really an amazing crisis that we're living through. It's once in a lifetime or once in a couple, 3 generations thing. And then the other thing is climate change. We are affecting the world's climate in catastrophic ways, and we did it by accident, and it's time to start undoing it. And these both are big science problems, and they're going to both require big data. And that's where you all are going to, dare I say it, save the world. So thank you. Thanks for having this conference.
Bill, just to kick it off, shifting from pandemic to the Planetary Society, what's your role in there? And what do you got to say about that?
Well, the Planetary Society, we're the world's largest independent space interest organization, and we're going to have 3 spacecraft. Humankind, is going to have 3 spacecraft arriving at Mars this week and next week. And this weekend is Planet Fest, a virtual event. Check us out at planetary.org. We have all kinds of world-class experts. But here's what it is. We advocate for space exploration in the US and around the world. We advocate for planetary exploration. And it's to answer these 2 questions. Are we alone in the universe? Is there somebody else out there? And then where did we all come from? Put another way, what are we doing here on Earth? And so Planetary Society was started by Carl Sagan. I took 1 class from Carl Sagan, a famous astronomer here in the US and around the world, very well known. And then I was at a board meeting of the Planetary Society 10 years ago. And I left the room. And when I came back, they had taken a vote, and now I'm the CEO. Now I'm in charge. So check us out at planetary.org and check out Planet Fest this weekend.
Awesome. And just speaking of Carl Sagan, one question I always have, and I think this is important in society, is this concept of mentorship. How do you feel about mentorship in solving problems, and who do you think was your greatest mentor?
Oh boy, my greatest mentor. Well, let me start with, I had a lot of great teachers. And people say, well, who was your favorite teacher? That's a tough call because you have teachers at different times in your life, different ages, and you have mentors at different stages of your life. So Mr. Flowers in 7th grade. I mean, Mr. Lawrence in 6th grade. Oh my, Ms. McGonigal in 2nd grade. And then I guess everybody, you want me to talk about Mr. Lang. Yeah, well, he was pretty cool. I had an excellent physics teacher, you guys, Mr. Lang, and that's what enabled me to get into engineering school and meet Carl Sagan and change my life. But my greatest mentor, I don't know. I was certainly very, very strongly influenced by Steve Martin, but he was not a mentor. My father was very influential, and I had an excellent scoutmaster. You guys, this is before all the weirdness with the Boy Scouts that we're dealing in the United States that we're dealing with now. I just had a regular experience as a regular Boy Scout. And I think from time to time about the movie, The Blair Witch Project. And like, get out of the woods. What is wrong with you people? No, if I have to spend a night in the woods, I'll be fine. I'll get through it. You want to get home? Follow the stream downhill. What is wrong with you? I don't mind if you don't come back. Sorry. Anyway, so I had a lot of people that were very strongly influenced me. And now as a guy, I'm old enough to get vaccinated in the States. Now I have a lot of people that are my age on whom I really rely for advice.
It just kind of, no. In shifting to that is, you've written a book on solving, these types of problems, and you've got a book on the great big world of science and using these principles to solve big problems. Part of this whole process.
Right here.
Oh, there you go. There you go. So,
nice.
What advice would you give to people? Because, I always look at, you start with mentorship, you learn from others, and then you start tackling problems and you run a process. What advice could you give to people watching here as to how to solve problems and how do your books help there?
Well, the idea, you guys, is these problems that we're facing now as a society, as humankind, are enormous. This virus that's killing people or making people very sick, just crippling global economies. This is a huge problem. So it's going to take a whole bunch of people to solve it. And in my opinion, which, as you know, is correct, the way to solve, that's a joke. The way to solve a big problem is to divide it into the smallest packets you can manage. Take your task, turn it into tasklets. And the other thing I tell everybody, whatever the heck it is you're doing, what is it you're doing? You're assembling furniture. You're solving software, an enormous coding problem. You're looking for a bug in code. Is just get started. You just got to get started. You can get overwhelmed by the enormity of the task or what you perceive as the enormity of the task. But if you get started, then I believe you can find ways to divide the job or the task into small parts and solve each one of those. And sure, there'll be the mythic, dare I use the management expression, critical path. There'll be the thing you got to have before you can do the rest of it. But that will all emerge if you just get started and then go at it with the idea to divide it into small packets, tasklets. Did that answer the question?
No, it's great.
Depends on the problem. But when it comes to climate change, we have to start doing more with less. In other words, have to be more efficient. We have to make transportation more efficient, agriculture more efficient, information distribution more efficient. But we also have to do more. We have to provide more electricity to more people in a sustainable fashion. So we got to work that problem from both directions. We got to put less carbon dioxide and other greenhouse gases in the air, but I'm pretty sure in the next 30 years, 25 years, we're going to have to actively take carbon out of the air through extraordinary chemical engineering processes. And we can do this. Let's go.
Well, take it from on the Earth to space. Let's talk about laser bees. I know this is an important initiative to you. So what are laser bees?
Matt, you're very nice to ask about the laser bees. Okay. That's very nice. Anyway, you guys, a real problem. I mean, it's extraordinary. And I've so told this story many times. I was at TED, the TED conference, and I said, the Earth could get hit with an asteroid and that would suck. And everybody, ha, 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 ha. No, it's a real thing, you guys. It probably won't happen this afternoon, but it's a real thing. And as we say, very low probability event, very high consequence event. So what do you do about an asteroid? You want to give it a nudge before it hits the Earth. You want to make it cross the Earth's orbit when we're not there, when the Earth isn't there. And so what you want to do is get out there 20 years ahead, 30 years ahead, after you've identified it, determined its path as best you can. Then the laser bees. This is my favorite. You might think, let's hit the asteroid with a rocket, give it a nudge. Let's blow up a nuclear, let's send Bruce Willis. Those really aren't the thing to do, because the asteroid may not be solid. It's tumbling in 3 axes. It's a complicated problem. But the idea that I really like as an engineer, and the Planetary Society sponsored a PhD program in, is to hit the asteroid with lasers, spacecraft with lasers. And then my joke, when there's in space, so there's no sound, just anyway. The ablating material, the stuff burning off the asteroid, we simulated this at Strathclyde University in Scotland, has momentum, and you'd give the asteroid a nudge. So what you do is have a swarm of these spacecraft, and that's why we started calling them the bees. Be like a swarm of bees, and you would hit the asteroid at the most effective times, like it's rotating, the dark parts facing the laser, the shiny parts facing away, and you give it a bzz, bzz, bzz. You guys, asteroids are tough. As the saying goes, it's like looking for a charcoal briquette in the dark. They're hard to find, and because of insolation, sunlight hitting them, their orbits change. They get nudged a little by sunlight and the outgassing of ice and stuff. But it's a real problem that the Planetary Society works on.
Yeah, that's cool. I never thought I would be talking about laser bees before, so it's a pretty exciting topic.
Very nice of you to bring it up, Matt.
Yeah,
It's a niche problem, a niche problem, but one that fascinates me.
It's cool. Bringing it back down, though, I think one of the big challenges facing society today is what's the truth, and how do we deal with the truth? We used to read encyclopedias. Now you read the internet. One of the questions from the kids out there is, how do you succeed in convincing climate change deniers to climate change believers? How do you use science, data, facts to persuade the deniers?
You guys, this is something I've been trying to do for 30 years, and I really haven't figured it out. But I know what you're driving at, and thank you very much for the question. Jim Hansen, testified in front of U.S. Congress in 1988 about climate change. And for whatever reason, people love to hate Al Gore. And part of it is that both of these guys are bringing bad news. Just bad news. I'm sorry, man. It's an inconvenient truth. Like this, the climate's changing and we did it by accident. So I'd say it just takes years. You just go into it. You think you're going to go to your holiday dinner with your crazy Uncle Bill, who's a climate denier, contrarian, might be a libertarian, is a very popular term these days for people who think everybody should be allowed to do whatever they like as long as they don't directly harm someone else. And you're not going to convince them at that one dinner. You're not going to change their mind at that one dinner. If you have somebody who believes astrology is true, that there's only 12 types of people in the whole world, and it depends where Jupiter was when they were born, you're not going to convince that person that there's nothing to it, that you can debunk it in straightforward fashion the first time you talk about it. But after a couple of years of chipping away, I believe many climate contrarians have come around. And as this other thing, we are all the heroes of our own story, of our own life story. Keep in mind that climate deniers or contrarians hold these beliefs just as strongly as scientifically literate people who have studied the problem hold the belief that the climate's changing. Obviously, we have caused this problem. No, it isn't. We couldn't have. No, there's no way. And it just takes a long time. And to the libertarians out there, I'll just say, you guys, you're not right.
Yeah.
You were talking about empathy. The thing to keep in mind is not everybody gets an even shake. If you think of the world as or your life or history as a racetrack, not everybody starts at the same starting line. And so that's what it's not in anybody's best interest to not have everybody have a high quality of life. Conflicts in the world through history are caused when this perception that goes back to when you are 1.5 years old. What is that? It goes from 1.5 up to 121.5. What is it? It's not fair. That's not fair. He's not being fair. And that just makes people crazy. So what we want is to treat everyone fairly. And that's part of the problem right now with convincing certain lawmakers of the importance of addressing climate change is the modern realization that what might be called large social justice is somehow tied with fairness and climate change. These are intimate things. Having populations that are going to be displaced, the sea levels rising, the desertification of their farmlands, they're going to be displaced. That affects everybody. And so we got a big row to hoe. Let's get started.
Well, there's then the next step, right? We've got over 7.5 billion people on Earth. Does it make sense, and how soon, if it does, to start moving people to Mars? I know we've got a lot of Elon Musk fans out there. So what are your thoughts on Mars, and does it even make sense to do?
Okay, I'm an Elon Musk fan. However, you're not going to go live on Mars, everybody. I love you more than life itself, but you're not going to go live on Mars. There's a few things, if you go there, you'll notice, right? First of all, it's really cold, fantastically cold on Mars. There's nothing to eat. There's hardly any water. And this other thing you will note, man, you will pick up on this other one right away. You can't breathe. You can't breathe on Mars, you guys. So even if I say to you, you want to live on Mars, go to Antarctica and live in the dry valley. No, not on the shore where the penguins are jumping and the orca are snapping at them and the blue whales are sucking in all the krill. No. You go to the dry valley where it hasn't rained or snowed in a century, and don't even breathe. Bring your own scuba tanks of air. People don't go. We have science bases in Antarctica, but people don't go there to raise a family and build swing sets and sliding boards. That's not what you do. It's too flippin' cold and there's nothing to eat. And Mars is so hostile. It's just so hostile you are to a human, to any living thing that we know of right now so far. But with that said, man, if I could go to Mars and come back, if I could go to Mars, work on a science base for a few months, years, and come back, okay, that's a whole nother. But we're not going to pull this off by going to Mars. You know, that's kind of a European view that, well, maybe it goes back before that when I think about it. But, you know, things are troublesome where you live, so you go to what came to be called the New World. You can do that for a while, but after a while you run out of world. And so, you know, when I was a kid, you guys, I went to the World's Fair in New York. The town's so nice, they named it twice. There were fewer than 3 billion people in the world. Now there's 7.5 going on 7.8 billion people. And everybody wants to breathe and live and drink clean water. And so we have got to change the way we're going about it. Going to Mars ain't going to be the thing. However, go to Mars, look for signs of life. That would be if a discovery of evidence of life, like fossilized pond scum, it would change the course of human history. It would be profound. Everybody would feel differently about what it means to be a living thing in the cosmos. It would be profound.
Well, and speaking of that, we have the ability to produce data unlike ever before, right? We can send all these engineers watching this right now can be pointed at one thing, right? And we can collect all this information and make a decision. If we could point everyone, what is the best use case for data and engineering for space exploration or societal progress? Where could we point all these people? What do you think is the most important problem to start collecting data on to analyze?
The most important problem, I guess, is climate change. But in the shorter term, we have these vaccines now, which are extraordinary. Messenger RNA, conventional adrenal style. Did I say that right? Adenal. I'm not saying it wrong, and now I'm getting tongue twisted. Derived from common cold style vaccines. We got those, but distributing them, the logistics of getting them to the populations that need them, and the analysis that you would do, a organization, a government would do, to find out where it would be most effective. For example, I'm in Los Angeles. I live in a very quiet neighborhood. For those of you who ever watched, if you're old enough to have heard of the television show Andy of Mayberry, this is where they shot it. Very quiet suburban streets. People walk to elementary schools and stuff. But also in Los Angeles are tremendous homeless populations. This is this crazy thing here in the United States where our wealth has been accidentally disproportionately distributed, largely or in some ways through the success of the tech industries. And then we have generations of people by long tradition who live together, multi-generations live together in close quarters, single dwellings. And this has led to the spread of the virus. Okay, so that sort of analysis would be really good to get that done. As we say, we want government, it's like a machine. You want the machine to have all the parts it needs, but no more. You want the government to have all the systems it needs, but no more. Well, we need a system to distribute the vaccines more effectively. And then climate change, people. Where are the most effective places to make changes? Farmland, freeways, highways for cars themselves. What's the most effective use of our intellect and treasure? You guys, I want you all to solve that problem. And we have, another 20 minutes or so you can get that done.
Yeah.
Really good.
Yeah, I think just keeping on problems here. Sometimes we fail, and we learn from it, right?
Well, say what you will about Elon Musk and SpaceX. Those guys and gals, they accept failure. When things go wrong, well, we got this part of it right, but this part not so much, and so they press on. That organization presses on, and that is cool. I just really admire that.
Yeah, I think that's kind of a really important point. In my career, a lot of my mentors taught me that we continue to learn from failure and adapt and overcome. What was one of the biggest failures in your life, and how did you learn from it?
Oh, man. Well, here's one. Where to begin? So here's one. I thought I was so cool. I was in engineering school. I pulled an all-nighter. I stayed up all night working on these problems. And by the time the test came 10 the next morning, I just sucked. And I just blew it. I blew the final exam and I got a terrible grade in this course that was fundamental. So getting enough sleep is really important. That's a real thing. And, it gets into one of my favorite ironic expressions is, I'll save time, I'll hurry. You make so many mistakes when you're in a hurry. Now, to be sure, we all have to hurry or hustle or keep it moving, especially in modern software industry. But I learned a valuable lesson. You got to get enough sleep or it's just things suck. And then, you guys, I've made so many mistakes. I've just made so many mistakes. And I guess most of them are a result of just being anxious, just being worried about the future. I'm not saying relax and don't plan. I'm saying just there's a modern verb, catastrophizing, imagining all the stuff that could go catastrophically wrong, and then you get paralyzed. You just don't get anything done. So I guess I'd give you those two.
Cool. All right. Well, I think we got one more question left. Before I do, I promised my sister, if this is recorded, to give a shout out to the teachers. The teachers having a really tough time right now across the country, across the world, right? So shout out to Rumney Marsh Academy. My sister's a teacher there in middle school.
Rumney Mark, science rules. Greetings,
Yeah.
Rumney Mark scientists.
There you go, Megan. So
Megan,
last
carry
question.
on. This is the last question? Oh my goodness.
Last question. Yeah, we're crushing through some of these. So you can use a little time here if you want. But and I think we have extra time afterwards. So if people want to ask more questions, we can. But I think it's a good one.
Oh, good.
Are aliens real? And I think, it would be great for there are many different variants of what an alien is. But like, are they real in your opinion?
Okay, so everybody, there's an expression, a leading question. Are aliens real? Leads to the question, are you certain there are no aliens? Or what do we mean by the reality of aliens? Have they come here in spacecraft and run needles up noses and not told anybody? No, that doesn't seem very reasonable to me. However, when I was in school, Frank Drake, who was an astronomer at Cornell University, proposed this clever, happy little thing that came to be called the Drake equation. And it's algebra for those of you who aren't familiar with. Those of you who are, let us celebrate it together. Frank Drake said, how many stars are there? How many of those stars have planets? How many of those planets have a planet that could sustain, let's say, let's say, liquid water or some other chemical solvent, liquid solvent that would facilitate the chemistry of life? Okay, then how many of those have emerged at a time when we could communicate with them? Have they come and gone? Have they not come into existence? Yes, and so on and so on. Well, everybody, when I was in school, Frank Drake and Carl Sagan, Kip Thorne, these guys would say, well, maybe there's a planet around every 100 stars. Like you got to find 100 stars, and if you did, you'd find one planet. Well, now everybody, with Kepler Space Telescope, Hubble Space Telescope, ground-based pan-star systems, people have decided that there's probably at least 10 planets around every star. So you take the Drake equation where you take 200 billion stars in a galaxy, at least 200 billion times that many galaxies. It ends up with a lot of stars, okay? And then instead of being a planet around every 100, there's 10 around every one. That's a factor of 1,000 right there. So it just seems unreasonable that there isn't something else out there alive that doesn't have the capability to wonder where it or they came from in the same way we do. How could there not be? Like, wow. But this expression, do you believe in aliens or aliens real? Aliens are something I don't think you can believe in. So the way you might believe in the earth is round, for example. It's not, you don't believe in them. You accept that they're very likely out there, and how cool would it be to discover evidence of life on another world? And it would be, as I say, it would change the course of human history. So yes, I strongly believe there are alien civilizations out there. I don't know where they are or how we'd get in touch with them or they'd get in touch with us. But understanding the fundamental nature of life, understanding the fundamental nature of the chemistry that creates life is a worthy use of our intellect and treasure. And I just think all the time, this vaccine is created in a way that Charles Darwin, Russell Wallace couldn't even imagine. Well, maybe they could imagine, but they didn't have any evidence for it. And so just think what the future holds when we can manipulate genes because we understand life, because we made discoveries about life on Mars or Europa, the moon of Jupiter, and it changed the world because we explored space. It's cool. So yeah, they're probably aliens. I don't know how to get in touch with them.
Probably not through Facebook or Twitter. But I would say there is one comment here made that I got to bring up here because I just find it funny. But apparently someone has solved global warming and our solution to Mars in this session here, Bill. So,
oh wow, thank you.
Yeah,
That's
yeah.
great.
I was like, oh, this is fantastic.
Nicely done. Yeah.
So one is we have to change how physics works.
Oh
Two,
yeah, we just change physics. Yeah.
just change physics, and then two, they would like to move the extra greenhouse gases to Mars that we've produced.
Zoom them.
Just zoom them in there. Just it works. And then Mars will get global warming, Earth won't, and then we all go live in Mars. That's the solution. I like it.
That's sort of a long-term thing. Keep in mind, everybody, if you like to think about this, Mars is really cold, but by our standards. But when you get near the Martian equator on the Martian summer day, it's right around freezing. It's right around 0 Celsius. It gets, many people believe, it gets slushy. The ice under the sand on Mars gets slushy. So maybe there's something still alive there that started living there 4.5 billion or 3.5 billion years ago. All right. But another interesting thing to keep in mind while you're thinking about keeping things in mind is climate change on Mars is cold, but it's not unbelievably cold because of the greenhouse effect on Mars. The Martian atmosphere is 95% carbon dioxide. It's very thin, 0.7% of the atmospheric pressure of Earth, but nevertheless, it's carbon dioxide that keeps Mars ever so slightly, not fantastically, unbelievably cold. And climate change on Earth was in many ways discovered on Venus, where James Hansen and his colleagues realized that the reason the Venusian surface is hot enough to melt lead is because of the greenhouse effect of the Venusian atmosphere, which is 99% carbon dioxide at 90 times the pressure of Earth. And so exploring these other two planets, what Carl Sagan called comparative planetology, led to the discovery of climate change on Earth and gives us, I think, a deep respect for what I like to call our place in space.
Absolutely. Well, that's all the time we've got today. Thank you so much. Again, we're giving away 500 copies of Bill's book, The Great Big World of Science. You want to show one more time, let everyone see it?
If you're homeschooling, they're 8 in a carton. They make great gifts. Earth Day is coming up.
All right. Well,
Valentine's Day. Oh, come on, Valentine's.
Yeah. There's nothing about more than love than
Because
science,
we have
right?
stuff about your heart. And so if you like to think about evolution, you guys, think not only your size and shape, number of fingers, but what you feel is a result of evolution. Whoa.
All right. Well, with that, thanks again, Bill. I really appreciate it. Thanks everyone for attending. Hope everyone has a great conference.
Cool.